Okay, here is some practice which is on page 15. Lithium sulfite. Here we know, according to the rules, lithium has one positive charge, so oxidation number for lithium is 1 positive, and we know, according to rules, oxygen has 2 minus charge, right? It's the oxidation number. And what is the oxidation number for sulfur? That is what we are finding here. So there are 2 lithiums, so 2 positive charges from lithium, and 3 oxygens means 3 times 2, 6 negative charges from oxygen, and it is a neutral compound, so it has to be equal to 0. The sum of the oxidation numbers must equal to 0. So sulfur will come up with 4 plus charge, 6 minus here, and if you have 4 here, 4 plus 2 is 6 positive charges, so 6 minus 6 plus will be 0, cancels out to be 0, right? Okay, so that is how we did this. And look at this one, aluminum chlorate. We know, according to rules, aluminum gets 3 positive charge, and there's only 1 aluminum, and there are 3 times 3, 9, so 1 oxygen gets 2 negative charge, and 9 oxygens will be 9 times 2, 18 negative charges, and there are 3 chlorines, remember that? So 3 times x, when you add it up, 3x is 15, and so x will be 5 plus. So 1 chlorine, the oxidation number for chlorine will be 5 plus. When you assign the oxidation number, you have to give individual atoms. So not just because there are 9 oxygen atoms, you don't say the oxidation number for oxygen is 18 negative minus, right? It is 2 minus. Okay, so that is how you assign the oxidation numbers. And let's do this one, H2PO4, dihydrogen phosphate ion, right? So it's ion, it's a negative charge here. So we know hydrogen is 1 plus, and there are 2 hydrogens, so 2 positive charges from hydrogen. What we don't know is the oxidation number for phosphorus, and oxygen is always 2 minus, so 4 times 2 is 8 negative charges, and it has to equal to minus 1. So when you add it up, you will end up with 5 plus charge for phosphorus. Now you can see, depending on the formula, the oxidation number can change. Here P4O8, oxidation number for phosphorus is 4 plus. Here H2PO4 minus, oxidation. So you can see, depending on the formula, the oxidation number for a nonmetal will be different. That's why you need to know how to assign the oxidation numbers. Now let's look at a couple of problems from this side. First, you need to figure out whether they are redox reactions. If it is a redox reaction, identify the substance oxidized and substance reduced, and also the oxidizing agent and the reducing agent. So if you look at the first one here, how do you handle this kind of question? You first have to assign the oxidation number for each element. Now this is a cuprous oxide or copper 1 oxide. Can you see that? So copper is 1 plus charge, and oxygen is always 2 minus. And here nitrogen, now we know oxygen is a given 2 minus, so nitrogen has to be 2 plus, right? Now let's go to the other side. Here oxide or cupric oxide, so copper is 2 plus here. Now can you see copper change from 1 plus to 2 plus, which means it has lost an electron. When you lose an electron is a negative charge, right? And the positive charge increases, so it is oxidation. As soon as you identify the oxidation reaction, circle the whole thing as the reducing agent. And nitrogen here is 2 plus, and nitrogen here in 2 is the elemental state. So according to 0 oxidation number. So 2 plus has become 0 means it has gained electrons. It has gained negative charge, right? So nitrogen is reduced. So NO, nitric oxide or nitrogen monoxide, is the oxidizing agent. Okay, so that's how you do this kind of questions. And let's look at this one. Zinc here is 0 because it's the elemental state, and this is vanadium 5 oxide, because vanadium is a transition metal, so vanadium 5 oxide. So oxygen is 2 minus, and vanadium has to be 5 times 2 is 10 negative charges, and there are 2 vanadiums, so a vanadium must come up with 10 positive charges, and there are 2 vanadiums to give that 10 positive charge, so one vanadium will be 5 plus. So if you go to the other side, zinc is already a monatomic ion, so 2 plus charge. Zinc has gone from 0 to 2 plus, so which means it has lost electrons. That's why lost the negative charge, so the positive charge has increased. So it is oxidation. Losing electrons is oxidation. And circle the whole thing. Zinc is the reducing agent. And here vanadium, in this side there are V2O4. So V2O4 is 4 times 2, 8 negative charges from oxygen. So we need to have 8 positive charges from vanadium, and there are 2 vanadium ions, so one vanadium is 4 plus. So you can see vanadium has gone from 5 plus to 4 plus, which means it has gained the electron. So it has reduced. Electrons is reduction. So which means we circle the whole thing, and this is the oxidizing agent. Hope this helps.